Hello, Algebra 2 students. In the last section of the notes, if you remember, we talked about finding the inverse of a function, okay? And in the second day, in this second part of 7.4, we're going to be talking about how to graph the inverse of a function. So if we look at the first example, it asks us to graph the function and its inverse. So the first thing I want to do is I just want to graph the function that we're given. Okay, so in order to do that, I'm going to get test points for x. So I'm going to do -2, -1, 0, 1, and 2. And then I'm going to plug each of these x values into our function, and then I'm going to get a y value in return. So if we plug in -2, we have -2 squared plus 1, so 4 plus 1, which is 5. If we plug in -1, we have -1 squared plus 1, which is 1 plus 1, which is 2. If we plug in 0 into our function, f of 0 is equal to 0 squared plus 1, which is just 0 plus 1, which is just 1. If we plug in x is equal to 1, we get 1 squared plus 1, which is 1 plus 1, which is 2. And then finally, if we plug in 2 for x into our function, we get 2 squared plus 1, which is 4 plus 1, which is 5. So I'm going to plot each of these points. Okay, our first point is -2, 5, which is right here. Our next point is -1, 2, and then 0, 1. And then our other 2 points are 1, 2, and 2, 5. So we can draw in this graph here. So that's the graph of the function that we're given. Okay, so that's step 1, but now we want to find the graph of the inverse. Okay, and remember, when we're going from our original function to an inverse, we're just going to switch the x and y. Okay, so basically I'm flopping those rows. So I'm going to have 5, 2, 1, 2, 5 in that first row. And in the second row, I'll have -2, -1, 0, 1, and 2. So if I plot each of these points, I have 5, -2 here. 2, -1 is here. 1, 0. 2, 1, and 5, 2. So we kind of have a sideways parabola. So if you remember in the 7.1 notes, we talked about when you are finding the inverse, we reflect over the line y equals x. And as you can see, we're doing that same thing here, okay? We're reflecting over the line y equals x. So the next part of this question, it asks, is the inverse of f of x a function? Okay, is our blue function, okay, is that a function? And the answer is no. Okay, and it's not a function because it doesn't pass what's called the vertical line test. Okay, and basically what the vertical line test says that if we can draw a vertical line through our function or through our graph, and if we notice that if it intersects at more than one spot, it's not a function. Okay, so we draw a vertical line through our graph, we see that it's intersecting here and here, so that means it's not a function. All right, so let's move on to the next example, and we're going to be doing the exact same thing, except now we have a cubic. Okay, so we're going to be graphing a cubic function. So we're going to use the same x values as we did before. We're going to use -2, -1, 0, 1, and 2. And we're going to plug each of those values for x into our function, and then we're going to get a y in return. So I'm going to scroll down a little bit, and I'm going to do my work in the space that we're given here below. So if we plug in -2, okay, we know that -2 cubed is -8, so we're going to have -8 over 2 minus 2, and that equals -4 minus 2. Okay, so when x is equal to -2, our y is -6. Okay, So when x is equal to -1, we have, well, -1 cubed is -1. So we're going to have -1 over 2 minus 2, which is going to be equal to -2.5. Okay, that's fine for now. We can make that an improper fraction. We could make it 5 halves, but 2.5 is just fine for now. So when x is equal to -1, we have -2.5. All right, not a lot of work to be shown here when x is equal to 0. Okay, y is -2. And then when x is equal to 1, we're going to have positive 1/2 minus 2. So it'll be 1 over 2 minus 2. And that's going to equal 3 halves, or 1.5. So 1.5, positive 1.5. And then when x is equal to positive 2, we're going to have positive 8 over 2 minus 2. Okay, 8 over 2 is 4. 4 minus 2 is 2. So now I'll plot each of these points. So our first point is -2, 6. And then we have -1, -2.5. Right there. We have 0, -2. We have 1. All right, I realize I made a mistake. This should be -1.5. So then our point would be right here. So 1, -1.5, and then 2, 2 is right here. So we can fill in our graph. It's going to look something like that. All right, and then again, once again, to go from our original function to its inverse, we're just going to switch those x and y values. So our x's are going to be -6, -2.5, -2, -1.5, and 2. And then our y's will be -2, -1, 0, 1, and 2. So I'm going to plot each of these points. All right, my first point is -6, -2, which is right here. And then we have -2.5, -1. Then we have -2, 0. Then we have -1.5, up 1, so -1.5, 1. And then finally 2, 2, which they overlap there. So we'll fill in this graph. Okay, and once again, we notice that there's that same reflection. Okay, we're reflecting it over the line y equals x. Okay, kind of we talked about that in day 1. So now it says, is the inverse of f of x a function? Okay, well, let's use our vertical line test here. So if we draw vertical lines, we're looking at the blue graph. Okay, we see that each of them only intersects our graph one time. So is the inverse of f of x a function? Yes, because it does pass the vertical line test. Okay, so because our vertical lines only intersect our graph once, then the function, or then the graph is a function. All right, so move on to the last page here, and on this one we're going to talk about the horizontal line test. So the vertical line test is used to determine if a graph is a function, okay? The horizontal line test is used to determine, based on an original function, if its inverse will also be a function. So if no horizontal line intersects the graph of a function f more than once, then the inverse of f is a function. So, maybe that's a little bit confusing, but we're going to look at an example and hopefully that'll help. So in number 1, example number 3, it says graph each function and its inverse if the inverse exists. So the first thing I want you to recognize is that we're given a domain. Okay, it says x is greater than or equal to 0. So if we set up an xy table to help us graph this, okay, we have to use values of x that are greater than or equal to 0. So we'll use 0, 1, 2, and 3. Okay, so if we plug in those values of x into our function, we'll get 0, 1, 4, and 9. Okay, so I'll graph each of those points. We have 0, 0, we have 1, 1, we have 2, 4, and then our third point is going to be off the graph, so I will just leave it like this. Okay, we'll draw in the graph of our function. So if we use the horizontal line test, so if we draw horizontal lines through our graph, okay, we see that each line is only intersecting the graph of our function once. So what that means is the inverse of f of x is also a function. So let's graph that. Okay, so to find the inverse, we're just going to switch the x and the y values. So our x's will be 0, 1, 4, and 9, and our y's will be 0, 1, 2, and 3. So our first point is 0, 0, our second point is 1, 1, and our other point is 4, 2. So we'll draw in the function, draw in the graph of that function, okay? And, well, because our original function passed the horizontal line test, we know that this is a function. We can also see that the graph of our new function in blue is going to pass the vertical line test, so then that's another way of determining that it's a function. So is the inverse of f of x a function? Yes, because it does pass the horizontal line test, okay? And when we're saying it here, we mean that f of x passes the horizontal line test, okay? So the inverse of f of x is a function because f of x passes the horizontal line test. All right, let's move on to the last example. The notes we're going to be doing the same thing that we did above, but now we have an absolute value function. Okay, so to graph this, I'm going to set up my xy table. Okay, and to get a good idea of what this graph looks like I'm going to test a few points here. So my x values are going to be -4, -3, -2, -1, 0, 1, and 2. Okay, give everyone a moment to write that down. And then we're going to plug in each of these values for x into our original function, and then we're going to get a y in return. So if we replace the x with -4, what's inside of that absolute value is going to be -4 plus 2, which is equal to -2. But because absolute value is never negative, okay, then the absolute value of -2 is +2. If we plug in -3, we're going to have -1 inside the absolute value sign. Okay, and because it's absolute value, it's going to be +1. If we plug in -2, it's going to be 0. And then 1, 2, 3, and 4. Okay, so if we plug in each of those values, if we plug in -1, it's going to be -1 plus 2, which is +1. Okay, we plug in 0, we get 0 plus 2, so our y is +2, and then so on. Okay, so let's plot each of these points. Our first point is -4, 2. And then we have -3, 1. Oh, I think I accidentally deleted my point there. So -4, 2, -3, 1, -2, 0, -1, 1, 0, 2, 1, 3, and 2, 4. Okay, so the graph of an absolute value equation looks like a V. Okay, and you might already be able to tell, but if we draw a horizontal line, okay, we see that we're intersecting at 2 points. Okay, so the horizontal line test says it has to intersect only once. All right, so is the inverse of f of x a function? No, because it does not pass the horizontal line test.